So in this session, we'll discuss mainly about the light, the topic light. First one is the reflection of the light or reflection of the wave here. What is the meaning or concept of reflection? When the waves strike the surface and it bounces back after striking a surface, we call this property of a wave as reflection. So property of a wave to change the direction when it strikes the surface, we call simply as reflection. If it is a sound wave, then we use the term echo for that. For example, a reflection of a light, the light changes the direction when it strikes the surface. Example, this is an incident light which strikes the surface, and the light which bounce off or light which bounce back, that is known as the reflected light. And the imaginary line which is perpendicular to the surface, that this imaginary line is known as the normal. And the angle of the incidence is the angle between the incident ray and the normal. An angle of reflection is the angle between the normal and the reflected. And according to law of reflection, these two angles will always be equal. So if the angle of incidence, the angle between the normal and the incidence, example, that is 30 degrees, then the angle of refraction will also be 30. So in this example, as you can see, when the light strike the surface, this is a surface. So what about the normal? Normal is always perpendicular to the surface. So the light which strike, that is the incident ray, and the angle between the incident and the normal, this angle is known as angle of incidence. And the light which bounce off from the surface, that is known as the reflected one. An angle between incident and the normal is angle of incidence. Angle between the incident reflected and the normal is angle of reflection. And the two angles will always be same, which refers to law of reflection. So these are some definitions. The light which strike the surface is incident. The light which bounce back, that is called reflected. The angle between the incident and the normal is angle of incidence. Angle between the reflected and the normal is angle of reflection. And normal is always the right angle or perpendicular to the surface. So formation of image by a plane mirror, like example, as we see ourselves in front of the plane mirror, we'll see our image. How we are able to explain the formation of the image by a plane mirror. So the image formed by a plane mirror is because of the reflection of the light when it strikes the surface. So example, this is the reflecting surface, the mirror is there, and for mirror one side is smooth and polished, the other side is having a silver layer. Now how the image is formed by a plane mirror, there is an object at this position. So when we look at this object, basically what happens, the two light rays, either object is a luminous object, so it will emit out its own light. If it's a non-luminous, then it will reflect the light from any other source. So when the two light rays which are coming out from the object strike the surface, it bounce back. So, and it will always follow the law of reflection. So when these two light rays bounce off, as you can see, these two light rays will never meet. They will never intersect by themselves. So what will happen when we are looking into a mirror, our brain always senses light is coming straight from the object. So as a result, when our brain recreate or reproduce these light rays, so as a result, these two light rays will intersect, and the position, the point where it appears that two light rays will intersect, that is a position where the image is formed. And this, what are the characteristic of this image? Or the properties of the image? this image is always virtual. It is upright, it is same size as the object, and it is the same distance. So these are the characteristics which the image will have, and it is laterally inverted. The term laterally inverted means that left appear right. So these are the characteristic of the image which is formed by a plane mirror. Is it clear that how the image can be formed by a plane mirror? So as you can see in this image which is formed by a plane mirror, so as you can see, for a person, this is a right hand and this one is a left hand. So but when looking into a mirror, what it appear left appear right and right appear left. So for the image, this is a right hand and this one appear to be a left hand. So when left appear right or right appear left, we call that as laterally inverted. This is a virtual image. Why it is a virtual image? Because we cannot see. If I place a screen back of the mirror, I don't see myself. We cannot see ourselves, and then that's the reason why this image is a imaginary or virtual. Then what is a refraction of the light? Refraction means property of a light to change the speed when it travels from one medium to another. We call that as a refraction. Example, this is a glass block. The light hit or light strike the glass block, that light is known as an incident. Because in air, the light is traveling faster, but as a result, when the light travel from air to glass, the light will slow down. This is an imaginary line which is perpendicular to the surface called normal. When the light is traveling from air to glass, it slow down and it bend towards the normal. That is called a refracted ray. And if we draw another normal, the light moving from glass to air, it bend away from the normal as the speed of the light increases. So this property of a light to change the speed, or property of a wave to change the speed traveling from one medium to another, is known as refraction. So that is the main reason why the object underwater appear to be bent, or why a swimming pool appear to be shallow, is due to the refraction of the light. Example, if we have a container which is filled with water, and there is an object underwater, so this is the object which is under the water. Now what happened? The two light rays which we'll use to explain how the image is formed. So when it moves from water to air, it will bend away from the normal. So two light rays, when it is coming out, it bend away from the normal. As you can see here, the distance between the two light rays will increase, so it means they will not intersect by themselves. So as they are not intersecting by themselves, when we look from here, our brain sense light is coming straight from the object. So when our brain reproduce or recreate these two light rays, as a result, what appear? It appear that the object is much closer to the surface. So same thing happen, that when you look at the swimming pool directly, at swimming pool you're looking at, so you will observe that it appear to be shallow. In practical or in reality, it will be deeper. So this is the imaginary image, imagination, which create this image, and it is also refers to virtual image. So due to refraction of the light, as the light travel from one medium to another, it changes the speed and the object appear to be shallower in water. So when a light moving from transparent, like encounter a transparent medium, some is reflected and some is transmitted. And the transmitted light means the light which is passing through will undergo a change in speed or direction, and as a result it will bend, and bending of a light due to change in speed is known as refraction. Then we can also use a term refractive index. What is the meaning of refractive index? Refractive index is ability of the medium to bend light. So tendency of a medium to bend light is known as a refractive index, and it is denoted by letter N. So example, if we say refractive index of the air as the light is moving, so refractive index of air is N1. Then refractive index of this medium, like it might be a glass or it might be water, so refractive index is N2. The angle of the angle in medium 1 is theta 1, and angle in medium 2 is theta 2. So what is the Snell's law? According to Snell's law, it shows a relation between the refractive index and the angle. So it states that N1 sine theta 1 means refractive index of first medium multiplied by sine of the angle in the medium 1 equal to N2, the refractive index in medium 2, into sine theta 2. Actually, in IGCSE, you have learned this formula, but you learned the final result of the formula. You did not specifically learn Snell's law. If you remember, we write n refractive index is sine angle I over sine angle R. So what is the reason for that? Actually, that is derived from the Snell's law. Snell's law is n1 sine theta 1 means refractive index in medium 1 and into angle in medium 1 is equals to refractive index in medium 2 multiplied by angle in medium 2. So if I say for air, we know the air refractive index is 1, so n1 is 1. What is theta 1? Theta 1 is angle of incidence. What is theta 2 is the angle of refraction. And refractive index of medium 2 is n example. So when I substitute the values, n1 is 1 sine and theta 1 is angle of incidence, n2 is n and sine theta 2, that is r. So r is multiplied, sine r is multiplied, other side it will be divided. So it will be sine angle I over sine angle r is equals to n. So you was directly using this formula. But now in A levels, you're not supposed to use this formula directly. You should always start with the Snell's law, because in A levels the question might be like one of the medium not be air. In O levels, every time one of the medium was air, either the light was traveling or moving from air to glass or air to water, or opposite was happening, moving from glass to air or moving from water to air. Always one of the medium was air. But now this time it's not necessary that medium will be air. It can be two different medium. Like example, light might travel from glass to water, so in that case, the refractive index is not 1. So you have to use the Snell's law, which shows a relation that n1 sine theta 1 is equals to n2 sine theta 2. Is it clear? So the Snell's law at the boundary between the two given material is the ratio of sine of angle of incidence to sine of angle of refraction. So this formula is important. You have to learn this, and we'll do some questions related to this topic as well later. So example, say you have sand and a car is moving towards the sand. So when the car is on the track, it is moving faster. But as a result, what happened as it enters the sand, the car will slow down. So that's it bent towards the normal. And opposite will happen as it move into a track back again. So the speed will increase and it will bend away from the normal. So same concept is there for light as well. So if light is making certain angle, like here in this example, light is making certain angle, so it will first bend towards the normal and then bend away from the normal. But if light is passing along the normal, then there is no bending of the light, it will pass straight. Only thing what we'll observe is a change in speed. But in when it is making certain angle with the normal, so here it is traveling fast, then it slow down and fast. And what is the observation when fast change to slow and making certain angle? So first it bends towards, and then moving from glass to air, it will bend away. But if it is passing along the normal 90-degree, so here it was moving, speed will decrease, fast, slow and fast, but bending will not occur as it is passing along the normal, which is the shortest path. So waves slow down, bend towards the normal and then bend away. And here the waves slow down, but it does not bend due to entering along the normal. The refractive index is the ability of the medium to bend light. So in O levels, we used to have this formula, the refractive index is sine angle I over sine angle R. But now we will not use, because this is only valid if one of the medium is light. Either light travel from air to glass, sorry, one of the medium is air. So light travel from air to glass or light travel from air to water, or opposite was happening. But now whenever we are solving the question, we will use the formula n1 sine theta 1 is equals to n2 sine theta 2. And what is N1 and N2? N1 is the refractive index of medium 1 and N2 is the refractive index of medium 2. And theta 1 is the angle between the normal and the incident, the light which entered the medium. So this one is theta 1 and this one is theta 2. And this was N1 and this one is N2. So when the light travels from one medium to another, like example, this is medium 1 and this one is medium 2. So what we will observe when we compare, we have the formula V is equals to F lambda is there. So if we say medium 2 is denser, means high density, and medium 1 is rarer, means low density. So when it enter a denser medium, the speed will decrease. So speed of the light will decrease. And opposite will be there. If the light is moving in a rarer medium, it will move faster or it will have a higher speed. Then what is the concept of total internal reflection? Example, this is a semicircular glass block. The light strike the surface and it bend away from the normal as it is moving from glass to air. So this is angle of the incidence and this one is angle of refraction. If we increase the angle of incidence, the light will travel at a, like here, first example, the angle of incidence say 30 degrees. The first example. If angle of incidence is 30, angle of refraction might be 45, example. Then what we did, we increase the angle of incidence, we made angle of incidence 35. So when we made angle of incidence 35, the angle of refraction will also increase. Now it is 70. If we further increase the angle of incidence, so what we'll observe, like example, when we increase the angle of incidence, say to 42, what we observe light is passing along the boundary, or light is traveling perpendicular to the surface, perpendicular to the normal. So when angle of refraction, if the angle of refraction is 90, this value of the angle of incidence is known as critical angle. So critical angle is actually the value of angle of incidence for which the angle of refraction is 90. If we further increase this angle, like example, critical angle is 42, but if we further increase this angle, what we'll observe instead of light will go out, it bounces. Like if the critical angle was 42, now what we did, we made 43. So when we change to 43, instead of light going out from the medium, it bounced back in the same medium, and we call that as total internal reflection. So total internal reflection is when angle of the incidence is greater than the critical angle. As you can see here in this figure, the light enter, and when we draw the normal, which is perpendicular to the surface, so moving from air to glass, the light bend away from the normal. The angle between the incident and the normal is known as the angle of incidence. So, and this is the angle of refraction. But this angle of incidence is not a critical angle. Why? Because angle of refraction is not 90. If we further increase this, if we further increase and we observe instead of light going out at a certain angle, it will travel along the surface. If the light travel, if this light travel along the surface, then what we'll say that now the angle of the incidence is known as the critical angle. So this value of angle of incidence, because the angle of refraction was 90. So this angle of incidence is known as critical angle. If we increase further, so what we'll observe, instead of light going out, the light bounce back in the same medium, and then it will go out from that medium, but light bounce back in the same denser medium, and we call that as total internal reflection. And for total internal reflection to occur, this angle of incidence is always greater than the critical angle. So here angle of incidence is less than critical angle, so simple refraction. Angle of incidence is equal to critical angle, or angle of incidence known as critical angle, because the angle of refraction is 90. And if we further increase, the angle of incidence is greater than critical angle, so light will undergo total internal reflection. Is it clear? The concept of total internal reflection. And so in this case, if we want to work out the refractive index, how we can work out the refractive index? Like example, if we say a refractive index of the glass is N1 and the angle of incidence, that is theta 1 here. The refractive index of medium 2 is N2 and the angle of refraction is, or theta 2, is 90. So we have the formula according to Snell's law. Always use the Snell's law. N1 sine theta 1 is equals to N2 sine theta 2. So N1 is a refractive index of medium 1 and sine theta 1. So theta 1 is what? It's the angle in the medium 1. So angle in medium 1 in this example, the second figure, is a critical angle. So I can say N1 sine C. C means critical angle. Equal to N2, the refractive index of medium 2, and sine 90, because the whenever angle of refraction is always 90. So we can say N1 sine C is equals to N2. Or because in case if one of the medium is air, so refractive index is 1, so value of N2 is 1. Refractive index of air is 1, so it will be N1 sine C is equals to 1. Or we can say N1 means the refractive index of medium 1 is 1 over sine C. So if we know the critical angle, we can find the refractive index of the medium, but the condition is that the second medium should be air. If the second medium is not air, then we'll use this formula. But if second medium is air, then directly we can say refractive index of the medium is equals to sine 1 over sine C. Then in optical fiber, the light will undergo total internal reflection. As you can see, this is an optical fiber, fiber optic. So this is source of the light. When the light is moving through this fiber optic or optical fiber, at this point the light should go out because it is moving from transparent medium. It strikes the surface, so it should go out, but practically it does not go out because the angle of incidence is more than the critical angle, so it undergo total internal reflection. Same thing moving from, and again it strikes the denser to rarer boundary, so it should go out, but it does not go out because the angle of incidence is more than critical angle, so it undergo total internal reflection. And we can use this total internal reflection of light in optical fiber to transfer information, or it can also be used in a field of medicine for endoscopy, like examining the internal organs. We can also use this fiber optic, or it can be used for endoscopy. Is it clear till this point? The concept of total internal reflection, critical angle, and refraction of the light. Any question or a doubt till this point? Then this is a new topic because the previous topic is what we have already discussed in O levels, but this is a new topic which is about intensity of the light. What is the concept of intensity? Intensity means how much energy is coming on unit area in 1 second. So example, you have a surface, so this is a surface, and the waves are coming on this surface and they transfer the energy, because wave is a mode of energy transfer as well. So how much energy is coming on a unit area, on a specific area in every second? So how much energy is coming on a unit area every second? What we call that as intensity of the light, or we can also say flux of the light. So if we want to work out the formula for intensity, is equals to how much energy is there on unit area So energy coming on unit area per second. So means divided by time. So what is energy divided by time? As we know, energy divided by time is a power. So this part for energy divided by time will turn into what? It will turn into power, because power is rate of energy transfer or energy per unit time. So instead of energy divided by time, what I can do? I can write a power here. So power divided by area, what we will get? We will get the intensity. And what is the unit of intensity? Because unit of power is watt and unit of area is meter square, so it will be watt per meter square. So how much power, you can also say how much power is coming on a unit area, that is also known as radiation intensity. So how we can work out the radiation intensity for different conditions? Because radiation intensity is always calculated over an area. So example, if you have a bulb or a lamp, so this is a bulb, and I want to find the intensity, radiation intensity at point P. But the thing is, the radiation intensity cannot be calculated for point, it is always for area. For example, I want to find the radiation intensity at a distance of 2 meter from the lamp or 2 meter from bulb. So, but because the radiation intensity cannot be calculated for point, it is always for specific area. So there will be so many points which are 2 meter away from the bulb. So when we join these points, when we connect those points, what it will form a sphere. My sphere might not look like a perfect sphere, but it will form a sphere. So whenever it will form a sphere, so what is the area of the sphere? Yeah, what is the area of the sphere? So it is in this figure it appear to be 2D, but in practical what will happen? It will be 3D, like a sphere will be there. Means the bulb is inside the sphere. It look like this, that it is a 3D figure. That object is inside the sphere. And what is the area of the sphere? Area of the sphere is 4 pi r square, where r is actually a distance. So we can say this r or d is same. So we can also say area of sphere will be equal to 4 pi d square, where d is the distance between the source and the point. So when we substitute a formula, we can say the intensity is equal to power divided by area. And what about area in this case? When we have a source which is emitting out energy in all the direction, so it will be power divided by 4 pi d square. Is it clear, this formula? So whenever you're using this intensity formula, it will be power divided by 4 pi d square or 4 pi r square, where d is actually a distance between the source and the point. So same way, if we are finding, like example, we are finding the radiation intensity of sun on the surface of earth. So example, this is our sun, and we want to find the radiation intensity of sun on earth, like how much radiations are coming on unit area in 1 second. So but earth at like a specific point, again as we mentioned, that intensity cannot be calculated for a point. Intensity is calculated for a area. So what we can say, the example, the distance between the sun and earth, which is about 1 astronomical unit, or in terms of kilometer, about 150 exponent 6 kilometer. This is a distance, so that is d. But again, when we are calculating a intensity of the sun, so there will be so many points which are at a distance of 1 astronomical unit from the sun. So when we make all the points, what it will give as a result, it will make a perfect sphere, like a complete sphere. And because it's a sphere, so intensity is equals to power divided by 4 pi d square, where d is actually a distance between the source and the observer, or source and the object. Is it clear, this question? The explanation of intensity. So intensity simply refers to how much energy is coming on unit area in 1 second. Because it's always about area, so we always take 4 pi d square. Then the dispersion of the white light. White light is a combination of 7 color, which is violet, indigo, blue, green, yellow, orange, and red. And each wavelength is each light color is having a different wavelength. And the one which is having a shorter wavelength or higher frequency will bend the most, which is a violet, and red is having the longer wavelength and shorter frequency. It will bend the least. As a result, it will spread into component, and we call that as dispersion of light.